Dear students, let us draw the lever structures of the sulfate ion. My dear students, first of all, sulfur belongs to group 6A. So it has 6 valence electrons. In the same way, oxygen is also the member of the same family. So it has also 6 valence electron. In order to write down the Lewis structure of any molecular ion, first of all, you will have to calculate the total number of valence electrons in that molecule. So total number of valence electrons of SO4 minus 2. There is one sulfur which has 6 valence electrons. There are 4 oxygen. One oxygen has 6. So 4 will be having 24. And minus 2 mean it has 2 extra electrons in its valence shell. So that will be 6 plus 24 plus 2, 32 valence electron. So sulfate ion has total 32 valence electrons. Next step is to draw their formula. This one is the skeletal formula of the sulfate and join all the atoms through single bond. And now by using these 32 electrons, we will complete the octet of all the atoms in it. Oxygen has 2 electrons in the form of bond pair. So in order to complete its octet, it must have 3 lone pair of the electrons. So total 1, 2, 3, 4, 5, 6, 7, 8. It will get 8 electrons. Now this oxygen is just like all these oxygens. So same will be the case with every oxygen atom. Mean every oxygen atom will be having 2 electrons in the form of one bond pair and 6 electrons in the form of 3 lone pairs. In this way, the octet of all oxygen atoms that is completed. It has 8 electrons and the 4 oxygen will be having 8 electrons each. Then 8 multiplied by 4, it means we have used all the 32 valence electrons for the completion of the octet of the 4 oxygen atoms. Now let us see the sulfur, which is the central atom. It has 1, 2, 3, 4, 5, 6, 7, 8. Sulfur also has 8 electrons in its valence shell, so the octet of the sulfur is also completed. Congratulations. Is it the Lewis structure of the sulfate ion? My dear students, no. In fact, the octet of all the atoms is completed, but still this is not the Lewis structure of the sulfate ion. Why? Because we are missing one thing, and that is the formal charge, which is very important because you know that the formal charge is basically inversely proportional to stability. So if the atoms they will be having high formal charge, that structure will be the unstable structure and that will not be the appropriate Lewis structure for that molecular ion. What is formal charge? If you want to watch my video lecture about the formal charge, I will give the link in the description of this video. Formal charge is basically equal to number of valence electrons that an atom possesses in elemental state minus number of electrons of atom in Lewis structure. Number of electrons given to that atom in Lewis structure. Now let us calculate the formal charge of all 4 oxygen atoms and that of the sulfur. The formal charge of all 4 oxygen that will be same because they are equivalent. Now, first of all, this oxygen formal charge is equal to oxygen belongs to group 6A, so it has 6 valence electrons. Number of valence electron in elemental state are 6 minus how many electron it has in this Lewis structure? 1, 2, 3, 4, 5, 6, 7. Now, while calculating the formal charge, the bonded electrons are equally distributed between the two bonded atoms. If there are two bonded electrons, then each atom will get one of that two bonding electrons. So it will be having 7. Its formal charge will be -1. It's -1. It is -1 because all oxygens are same. It is -1 and it is also -1. No, what will be the formal charge of the sulfur? We will say formal charge of the sulfur is equal to sulfur is also a member of the sixth group. So it has 6 valence electron in the elemental state. Now, how many electron it has in this Lewis structure? It has 1, 2, 3, 4 electrons. So 6 minus 4, that will be equal to +2. It will be having +2. Now, my dear students, every atom has some formal charge. Sulfur +2, oxygen -1, this sulfur -1, this oxygen -1, and all the oxygens are having -1 charge and sulfur +2. It means all atoms have high formal charge. If they have high formal charge, then they are unstable. This overall structure, in this structure, the octet is no doubt completed, but this will be a highly unstable proposed Lewis structure of the sulfate ion. To make it stable, we will have to reduce the formal charges. Now, in order to reduce the formal charges, oxygen will use its lone pair of electrons. Suppose one oxygen uses lone pair of electron to form another bond with the sulfur, then the structure will be S double bond O, single bond O, like this. Now this oxygen will be having two lone pair of electrons and two bond pairs, while all other oxygens, they are same with bond pair and lone pair. 2 electrons in the form of bond pair and 6 electrons in the form of the lone pair. Now all these oxygens, they have not used any of their electrons, so their formal charge will remain same, -1. And now let us calculate the formal charge of the sulfur and this oxygen. Now formal charge of this oxygen will be, it has 6 electrons in its valence shell, and now it is having 1, 2, 3, 4, 5, 6. That is 0. So it means formal charge of this oxygen is 0. Now what's about the sulfur? The formal charge of sulfur is, it belongs to group 6 minus 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it has 5 electron, that will be +1. It means moving the lone pair of one oxygen atoms to form the double bond between oxygen and sulfur has reduced the formal charge of two atoms. Sulfur before it was +2, now it is +1. Oxygen was -1, now it is 0. So formal charge is somewhat decreased in this structure. It means the stability will increase. So this Lewis structure will be more stable as compared to the other ones, the first one. Now let us make another structure in which another oxygen contributes its lone pair to form the double bond with the sulfur. Now it will be something like this. Now both these oxygens, they will be having two bond pair and two lone pair of electrons. But these oxygens, they are just as before. They will be having one bond pair and three lone pair of the electrons. Now, my dear students, when this oxygen made double bond with the sulfur, its formal charge was 0. And again, the formal charge of this oxygen will be 0, just like we have already calculated. And these two will be -1. Now, let us calculate the formal charge of sulfur. It belongs to group 6. And how many electrons it has? 1, 2, 3, 4, 5, 6. So formal charge of sulfur is 0. Now in this case, the three atoms, they have got 0 charge. Only 2 atoms are having -1 charge. So this one is the most stable Lewis structure of the sulfate, and it will be written as S double bond O, double bond O, 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 and the actual charge on this sulfate will be -2 because of these two oxygen atoms. And if you will like to write down just its dot structure, SO4, you will write down 4 electrons here. Similarly, 4 electrons between this oxygen and sulfur to show the double bond. 2 electrons here. Similarly, 2 electrons here. Both these oxygens, they will be having 2 lone pair of electrons, and these oxygens will be having 3 lone pair of electrons. So this one will be the dot structure, and overall the square brackets will be placed and charge will be -2. So this one is the Lewis dot structure of the sulfate ion, and this shows the maximum stability as the contributing atoms they have minimum formal charge. That was all about the lecture. Take care.